Good morning, my YouTube viewers. It is Crystal here, and I'm just here because I wanted to do a code review for you. What I'm doing is I'm doing an exercise in cosine similarity, and I used the Kaggle competition to do the cosine similarity. I didn't do what Kaggle wanted me to do, but I will at some point. But I just used cosine similarity on this competition questions just to see how well I could score just using cosine similarity, and I scored 32%, which isn't too bad considering the fact that this competition question, which is contradictory, my dear Watson, wasn't just in English, it was in lots of different languages, and it had text in like lettering that we don't use, because I think, yeah, we use a certain type of lettering and then have text and other lettering. So I think 32% isn't too bad for this competition question using cosine similarity, and that's what I wanted to do, just check it, and to check cosine similarity between two columns of data. Now I have checked cosine similarity between two strings of text in the past, but I just wanted to see what would happen if I did it between two columns of data. So the first thing we'll do is we'll just talk about the problem statement for this competition question. It said if you have two sentences, there are three ways they could be related. One could entail the other, one could contradict the other, or they could be unrelated. Natural language inferencing, NLI, is a popular NLP problem that involves determining how pairs of sentences consisting of a premise and a hypothesis are related. Your task is to create an NLI model that assigns labels 0, 1, or 2 corresponding to the entailment, neutral, and contradiction to pairs and premises and hypotheses. To make things more interesting, the train and test set include text in 15 different languages. So it's got text in 15 different languages. So the first thing that we're going to do with this problem is we're going to import the libraries. And so what I imported was NumPy, which is used to carry out linear algebra, but also numeric computations and NumPy arrays. And we imported pandas SPD, and what that does is that creates data frames and maintains them. We imported matplotlib SPLT, which is a graphics library, and it takes all of the data points that you want and puts them into a graph, and Seaborn SNS, which is a higher level graphics library written on the top of matplotlib. So after we've imported our libraries, what we want to do is we want to load the data set. We use the OS library to go into the operating system and get the data set, and the data sets we have are train, test, and sample submission. After we have loaded the data sets, we want to read them, and so we use pandas, the read CSV function, to read the three data sets into the program, and I define them as train, test, and submission. So here's your train data set. It has ID, premise, hypothesis, language, abbreviation, language, and then it has a label. But the only thing that we're going to be using in this exercise is the premise, hypothesis, and label. And then we've got the test, and the test is the same format as the train, except for the fact that it doesn't have a label because we're going to have to make a prediction on the label. And you can see that the test set has different types of writing. We've got our train info. You can see they're all object files except for the label, which is an integer. We've got our submission file, and that's the format that Kaggle wants to see when you submit the data. We wanted to analyze the target, so the target is the label. So we used SNS, that's Seaborn.displayTarget, target, to see that you had, you didn't have an equal amount of 0, 1s, and 2s, but they were close. We have a box plot, so you can see we've got a box plot of 0, 1s, and 2s. And I did the test file again. I don't know why I did the test file again, but I did it. Now what we're going to do is we're going to use TF-IDF vectorizer, which is in the sklearn library. So from sklearn.featureextraction.text import TF-IDF vectorizer, and also from sklearn.metrics pairwise import cosine similarity. So this is the work that we're going to do to check cosine similarity on these two columns of data. TF-IDF equals TF-IDF vectorizer, stop words equals English, lowercase equals false. Cossim is a blank array. For R in len test, doc1 equals test premise.locr, doc2 equals test hypothesis.locr, docs equals doc1, doc2. TF-IDF vector equals TF-IDF dot fit transform dots. Similarities equals cosine similarity TF-IDF vector. Cosine sim dot append similarities. Cos sim equals NP array cos sim. Cos sim sub equals cos sim, and that's going to be like the first digit of it, because when it comes out you had to convert it to an array, and when it comes out it's like a 2 by 2 matrix. But obviously when we submit the data we don't want to see a 2 by 2 matrix, so I had to go in and find out how to just get the first number out of it, and this is the code that I was able to use to get the first number out of it. And then it says print cos sim sub, so it gives you your cos sim sub, and it said cos sim sub shape is 5195, so that's how many you have in the test. So now what we have to do is we have to prepare our submissions. So we have to number our submissions. So prediction is a blank array. For P in range len, cossim sub, if cossim sub P is less than or equal to 0.3333, pred equals 2. LF cossim sub is less than 0.3333 and cossim sub is less than or equal to 0.6666. Pred equals 1. LF, if cossim sub is greater than 0.6666, pred equals 0. And then prediction append pred. So we've appended all of these to it, and after we do that we prepare our submission. Submission prediction equals prediction. Submission to CSV equals submission.csv index equals false. Submission equals PD read CSV submission. So you can see our submission, and most of them were 2s. And so whenever I submitted the data to Kaggle, I got a 32%, which isn't even 50%, but it was something, you know, and so that shows, well, this worked, and it worked. It got on the leaderboard, and it wasn't what Kaggle wanted, but I will be doing what Kaggle wanted at some point. I just wanted to try out cosine similarity, see how it worked on columns of data. So now you know how to use cosine similarity with columns of data. So I'm going to go ahead and close this video because I've covered all of the important data that I wanted to cover. But I want to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. Thank you so much for watching this video, and I look forward to making more videos for you in the future.